Okay, today we are going to talk about areas of triangles and parallelograms. Now, we have already talked about the areas of triangles, so that'll be more of a review for you. However, the parallelograms, that is some new information that we're going to talk about. So the first part of our notes, the area congruence postulate, says if two polygons are congruent, then they have the same area, which if you think about it, it makes sense because if I have a square and both of these sides are 2, and I have another square, both of these sides are 2, the area, what you have inside of here, they should be exactly the same if they're congruent. Okay, so it kind of makes sense a little bit. Our parallelograms, it says either pair of parallel sides can be used as bases. Either pair. So I've got one set of parallel lines and two set of parallel lines. Either one of these could be bases. It really doesn't matter which direction it is. Then the important part, this next part here, the height is the perpendicular distance between my two bases. So it comes down from the top and is perpendicular. Okay, so I'm looking at that vertical height right there. So that's my height. And then we're going to say that our top and our bottom is our bases in this case. Okay. A lot of times what they do with these parallelograms is they start from one of the corners and draw the height down from there. Really, there's no reason for it. They just tend to do that. The area of a parallelogram then says the product of a base and its corresponding height. So product means to multiply. So down here I'm going to label my base. A lot of times the base is like the bottom of my object, and my height again comes down and is perpendicular. So it says the area is the product. So I multiply my base and my corresponding height. So this is equal to my base times my height. All right, the area of a triangle. Now this is what should be review for us. So the area of the triangle, it says, is 1/2 the product of the base and its corresponding height. So I've got my triangle here. My height, again, comes down from that point and is perpendicular. That's my height. And my base is what it comes down perpendicular to. So the area is equal to, there's two ways you can write this again, is equal to 1/2 times my base times my height. Or I can say my area is equal to my base times height divided by 2. Either one is totally fine. Okay. Now what I want you to do is I want you to go in and grab your pink sheet and fill out the space for your parallelogram for the area there. Make sure that you have in there that you have your height here. You label that with an H, and your B is your base. And I would like you to write like H equals height and B equals base, and then fill in the area there. Okay, then once you do that, then we'll come back and we'll look at our next example. So this next example here, it says find the perimeter and area of each polygon. Again, perimeter, you just add up everything on the outside. So this first one, my perimeter, if this is a parallelogram, that means I know that this should be 30 and this right here should also be 20. So I add them all together. So I've got 20 plus 20 plus 30 plus 30. And when you add all of those together, you should get 100. And again, don't forget to label this. In this case, it doesn't really tell us, so this is going to be units. Our next one, then our area, this is a parallelogram. So I just take my base times my height. My base is going to be this bottom number right here. And my height is not 20, but it is 17. It's what comes down and is perpendicular. So I've got 30 times 17, which equals 510. And again, they didn't give us feet or a specific unit, so we just say units squared. My next one, a triangle. Perimeter, again, add up everything on the outside. So I've got 10 plus 17 plus 21, which ends up equaling 48. As long as I did my math right there, 48 units. Then the area, you take 1/2 of my base, which is 21, times my height, and the height of this triangle is 8. So when you multiply this, again, double check my math here, but I got 84 units, and because this is area, this should be units squared. Okay. Our next example, example 2, it says the lengths of the hypotenuse and one leg of a right triangle are given. Find the perimeter and area. Now, in this case, they don't give us our triangle, so go ahead and draw your triangle. Okay, let's see. It does tell me the lengths of the hypotenuse and one leg of a right triangle. So make sure that you've got your right triangle here. So I've got the right triangle. The lengths of the hypotenuse and one leg are given. So it tells us our hypotenuse is 26 and one of the legs is 24. I need to try and find the perimeter and the area. So before I can actually do that, I could do that if I knew what this side length over here was. I'm going to call that side length X. So I don't know what that is. Okay, so looking at this, I see I have a right triangle. When I know two side lengths, I know my hypotenuse and I know one of my legs is 24. How do I find that? Well, this is where we look into our toolbox here, and I need to use my Pythagorean theorem. So my a squared plus b squared equals c squared. So I've got 24 squared plus x squared is equal to 26 squared. So just double check my math on this. I've got 576 plus x squared equals 676. You subtract 576 over, so x squared is equal to 100. The square root of 100, x is equal to 10. So now I know, okay, this right here is 10. Sweet. Now I can go in and I can actually find my perimeter and area. So my perimeter, add up everything. 10 plus 26 plus 24. Oops. That should be a 24. There we go. Add those all up and we get 60, and in this case they did tell us it is centimeters. My area then. Now my area is 1/2 of my base times my height. I know my base is 24, so 1/2 of 24. Now my height again comes down perpendicular, and as I look over here at my triangle, I can see, oh, okay, my 10 is actually my height because that's what's coming down and is perpendicular. So I take 1/2 of 24 times 10. 1/2 of 24 is 12. 12 times 10 is 120, and we're talking about centimeters squared here. All right. Now, example 3, we have a parallelogram here, and I need to this time try and find what is the height. They already give us the area, and so I need to think back, okay, how do I find the area of a parallelogram? The area is equal to my base times my height. So I'm going to just take the numbers that they give me right here, this 153. I'm going to take those numbers that they give me, and I'm going to go ahead and just substitute those in. So my area should be, let's see, it says it's 153 is equal to my base is 17, and my height, I don't know, that's x. So now I have an equation that I can solve for x. Divide both sides by 17. So x should equal 9 feet. X is equal to 9 feet there. All right, my next example, example 4, the base of a triangle is twice its height. The area of the triangle is 36 square inches. Find the base and the height. All right, again, I'm going to go ahead and draw this. It's hard for me to do this sometimes without a picture. So I've got my triangle. These triangles look just awful, and I apologize for that. My height, let's see, do I know what my height is? No, I don't. So I'm just going to label that H, because I don't know what my height is of my triangle. It does tell me, however, the base of a triangle is twice its height. So if my height is H, my base down here should be 2H. And it tells me that the area is equal to 36. Now to find this, again, I'm going to go ahead and use my formula. My area is equal to base times height divided by 2, or 1/2 your base times your height. Now I know my height is H. That's going to stay the same. My base here is 2H. So what I'm going to do is I'm going to go ahead and substitute this 2H into my B and write my equation. I'm also going to substitute in my 36. So when I do that, I've got my area, which we said is 36, is equal to my base, which is 2H, times my height divided by 2. I'm going to go ahead and simplify the top part of my fraction. So I've got 36. H times H is H squared divided by 2. Now from here, I can see, okay, I could multiply by 2, get rid of that bottom part of my fraction, but 2 divided by 2 is just 1. So I'm going to write this up here. I've got 36 is equal to H squared. Take the square root of both sides, and the square root of 36 is 6. Let's see. So if H is 6, which is my height, let's see. Oh, this should be 6 inches. That's my height. That means my base is 2 times 6, which is 12 inches. Okay, my very last postulate, it says the area of a region is the sum of the areas of its non-overlapping parts. So if I were to, I don't know, just draw something here where I've got like a triangle right next to a square. The area that's on the inside of my triangle and my square, I would find the area of my triangle and add that to the area of my square. That's what it's saying. I can add those two areas and it should equal the area of my entire figure here. So this very last example, I see I have a nice red barn here, and I have to paint this. I actually had to paint something similar to this in high school. Let me tell you, it takes a long time. But you need to buy paint so that you can paint the side of the barn. Only one side. I guess the farmer doesn't care about the rest. It says a gallon of paint covers 360 square feet. How many gallons should you buy? So I need to look at this right here. I see I have a triangle and I see I have a rectangle right there. Okay, I know I could probably pretty easily figure out the area of my rectangle. So let's go ahead and do that. Let's find, I'm going to say the area of my rectangle. Again, we take our length times our width. So that is 18 times 26. 18 times 26 gets me 468. Okay, I found that. Awesome. Now let's go ahead and look at this triangle. And as I look at that, I can see, okay, I don't actually know what this side or this side is. You can see these little tick marks here and here showing that those two sides are congruent. And I know that this right here is 26. Now what I'm going to do is I'm going to redraw this triangle down below, just so it looks a little bit bigger, a little bit nicer, so I can kind of see. I know these two sides are congruent, and this right here is 26. Okay, if that's the case, I need to, in order to figure out what this is, I need to figure out what my base is and what my height is. And they both should be x because they are exactly the same. So to find what x is, I need to use my Pythagorean theorem. So I've got x squared plus x squared is equal to 26 squared. So I have 2x squareds is equal to, let's see, 26 squared is 676. Divide both sides by 2, so x squared is equal to 338. I'm going to take the square root of both of those. Sorry, this should be an equal sign here. So x is equal to, well, actually, I'm just going to go ahead and leave it. The square root of 338. Okay, I'm not going to approximate my values yet. Now, to find the area of my triangle, I'm going to write this back up here. Okay, we've got the area of our triangle then is half of my base times my height. So or base times height divided by 2. So my base and my height in my triangle here, I found both of them were x and x. It's my base and my height. So I've got, I've got the square root of 338 times the square root of 338. And you take that and divide by 2. And what I ended up getting after solving this is 169. Now, what I'm going to do, if that's the area of my triangle, I'm going to take the area of my triangle plus the area of my rectangle here, so I can figure out what is the total area so I know how many gallons I need to then buy. So I'm going to add those two numbers together. So 468 plus 169 is equal to 637. So that is my total area. And if it tells me that a gallon of paint covers 350 square feet, I'm going to take that number, 637 divided by 350, which I end up getting a decimal. I think it's like 1.82, which I know I can't buy 0.82 of a gallon. So I'm going to round up and I'm going to end up buying 2 gallons. Of paint. So if ever you have to paint a barn, you can figure out what the area is and figure out exactly how much paint you need without having to buy a ton of extra. All right.